Yep. Easily one of the most recognisable bass riffs in existence, New Order's Blue Monday. Now, what I just wanted to do, use that for introduction, was that I wanted to show how the bass and reading tablature, or the lead, which you cannot see at the moment, can be adopted to show the principle of arrays. Now, what we have here is, you could see, this is my bass guitar, my Harley Benton, or my Rico Benton as I would call it, because it's obviously in the shape of a... Okay, so what I'm saying here is that an array could be seen in several different ways, looking at this analogy. And the first analogy is that each one of these strings seen as an element within a 4-element array. Obviously position 0, 1, 2 and 3 for strings E, A, D, G. And which we will see later, the tablature, right, is basically the position in which fret you will play. So for the first note of New Order's Blue Monday, A string, in other words the second string from the top, okay, and basically that would have a value there of 5, okay, so you strum that a few times, and then we alternate back to the same string to the 3rd fret, and then we hammer on, or we can pluck the 5th string again. So that would read something which I will show now as 5, 5, 5, 5, 5, 5. How many notes you are hitting on the 5th fret? You lift your finger up for the 3rd fret, so that would read 3. Back on for the 5th fret. Okay, so in my array there will be no value here for the 1st string. Okay, but there would be a value for the 2nd string here. Now, which we will come to, unfortunately, there is a bit of a problem, and I better say this now, and this is one rule. The one big abiding rule of tablature is very, very simple. It's upside down. Whoop, whoop. Okay, and there is an extremely simple reason for that. Okay, if you turn your guitar, whoop, don't do that. If you turn your guitar on your lap and you look down, the thinnest string is now at the top and the thickest string is at the bottom. So that's why tablature is upside down. So, sorry for that aside, so in tablature, this wouldn't be, those notes wouldn't show up on the 2nd from top, they'd be showing 2nd from bottom, but I'll just go through it again. Okay, and then you go to the 2nd from bottom string as we're looking at it now, and pluck on the 3rd fret, the string on the 3rd fret, and then go to the 5th fret, back up here to the 3rd fret of the 2nd string. Now, this would show up in tablature as obviously being upside down, but we could see this as being a 1D array, where a 1D array of integers, where each value of the 4 integers would represent which fret you were playing. Okay, whatever fret you're playing. Okay, so what I'm going to do now is then I'm going to extend this on to to show how it would represent in a 2D array. Okay, now in a 1D array all we're doing is representing what's on each string, and each value represents to whatever string it's on. So if you were to play the bass doodle from what was it going to say starting whoops, okay, I'll have to go back over that. Beep. If you were to play the bass riff for Cunning Stunts from Metallica, you would start off here, okay, the 14th fret, but in tablature it would be shown it as this. In the array values that we would have, it will be the first value will be 14, okay. So you would start off at 14, 16, 14, 16, and slide to 13, okay. Now in our 4 value array, it would be saying 14, 16, 14, 16, 13, okay, and then obviously it would go, right, it will start off that way. But the analogy is, as I said before, that if we were using it for a 1D array, okay, each one of the values in that 1D array could be seen as what fret you are playing. Okay? Now, if we were to extend this onto a 2D array, you might say to yourself, hang on a second, we don't really need the values of the frets at that point in time. How you could represent tablature in a 2D array would be each one of the frets would be an array within the 2D array. Okay? But here is the thing, is that each one of the values will be either true or false. In other words, that if I said here, okay, on an array 0, starting up here, okay, and you've your 4 values there, you could actually say then, okay, if you were to play, let's say, that same riff again for New Order's Blue Monday, we come down here. This is array 0, we're playing nothing there, so no values there, okay, and what we could have is an array of booleans, and if that boolean is set to true, we could say yes, that string is the one we're playing. So what we could do is that if we look at it here, 0, 1, 2, 3, right, so if we go down to our 4th array, okay, and remembering that it's kind of upside down, so the corresponding, each one of the arrays would have 4 boolean values, and the first value will be set to false, it's not being played. The second value will be set to false, it's not being played. But the third value will be set to true because it is being played. Alright, so so we could represent tablature in a 2D array as well. Okay? But the point is this, is that would be a higher level of complexity. We wouldn't need really to have a 2D array of values for tablature, because the 1D array really does it fine as already.
So I suppose the big thing that I really wanted to show here was that everyday examples of, let's say playing the guitar as such, well, this is the lead guitar or rhythm guitar, whatever you want to call it, and the programming concepts are aligned, and it doesn't have to be stuffy kind of geeky talk and all that. What I'd like you to do is take the examples that I've done and actually apply code to it, but don't apply strict Java code. Look about you. See, is there other examples within everyday life that we could say, yes, an array could be applicable to that. An array could store those values that are going through and so forth like that. So I'd like you to do that. And what I will do in future videos is actually show this implementation within code. But all it's left for me to say is thank you for your patience, attention, and time. Take care and keep up the coding. More importantly, just keep up the guitar.